All right, let's talk this morning about in-memory OLTP tables in SQL Server 2014. Some applications really would benefit from using this feature, some wouldn't. Okay, for those of you who know what the table creation syntax is, in 2014 you can do with memory optimize equals on. So here's some of the pros about these type of tables. Number one, it's faster, right? I mean, what's faster than disk or memory? If you have to read from disk and then put that into memory, what's going to be faster if it's already in memory, right? In some cases, you're looking at 50 to 100 times the speed. This is ideal for some OLTP applications, specifically for certain tables. Notice I'm saying it's ideal for some OLTP applications, not OLAP applications. A big difference. And the funny thing about OLTP or in-memory OLTP is the amount of people in OLAP who think that it would be perfect for one of their staging tables or something. They have no idea what they're talking about. It's not that. It's not for that type of purpose. That's not going to be where you're going to get the greatest benefit. Okay, and then this also one of the pros is it eliminates the entry table bottlenecks. Okay, so for those of you who have designed applications, you know that one of a good example would be like a queue table. Another example would be like an entry table. But for those of you who've designed applications, you know that one of the problems in OLTP applications, queue table is a good example of this, is where you have to load a table where you're going to be inserting, you're going to be updating, you're maybe deleting. Sometimes it's just inserts and updates, sometimes it is deletes, and you're going to be reading from, right? Think of the distribution database in replication. It has two tables, the commands table and the MS-REPL commands and the MS-REPL transactions. Those tables, just heavy traffic. And you don't ever want to do something like a count star from those tables because, I mean, you're going to be either blocked or you're not going to get what you need. I guess it depends on your replication. If you don't have really much going on, you could always get the information, okay? Well, the thing is, those are very heavily trafficked tables. You have a lot of updates, you have a lot of inserts, you have a lot of selects, and you even have a lot of deletes going on, right? And so that's a good example of a table. In fact, if we go to the next slide here, that's a good example of a table that would be really optimal for this in-memory OLTP. The other thing, too, as well, is that the user cares about the latest information and the speed of how quickly they can obtain that information. Reason why I use that as an example, most people don't keep transactions or commands for 100 days. It would be stupid to do that unless you just, again, don't have a lot going on. Okay, you care about the latest information. Queue table is another great example of that, right? A queue table is, the purpose of a queue table is to load. That's what it's for. It's going to be to load some other table. So it's going to have, it's going to be very similar in its OLTP structure. Okay. That being said, there are some disadvantages to this. Number one, it's completely incompatible with some database designs, such as foreign keys, right? Also, this isn't a data warehouse solution for OLAPers. It's called in-memory OLTP, right? An OLAP environment, for instance, when you have, let's say, a staging table, you have a bulk insert into the staging table, and then you have a read of that, and you insert it into a format. That's not going to be something that you necessarily want to throw in-memory OLTP for. And the reason why is because that may not actually be your bottleneck, number one. And anyone who's worked in an OLAP environment knows that generally it's the select query. Off of that, you insert into another table from your staging table. It's going to be that select query that's going to be your problem. And it's not because of speed. It's because you often create a bottleneck with CPU. That's one of the reasons why OLAP environments have to be a lot better at the max DOP settings. Okay. Also, in-memory tables don't allow for change very easily, which is either a bad thing or a good thing, depending on who you ask. It's a good thing in that it really makes you stop and think about your design. It's a bad thing for people who don't, right? In general, SQL Server is not MongoDB. And what I mean by that is, if you're just constantly adding columns to your tables, you really are using the wrong tool, okay? And then, you'll find many exceptions to this in the world of SQL Server, but it is not going to be good at just constantly, as SQL Server in general is not good at constantly changing the structure. You need to be thinking about that beforehand. Roll with it, okay? Financial data, for instance, let's say stock data. You get the price, you get the date, you get the volume, you get the high, you get the low. But for the most part, that's pretty much been the way it's been the last 30, 40, 50, 60, 70 years, right? That's what people care about. You're not going to change a lot of that. You may add things to other pieces or other applications, but for the most part, this is what people actually care about with those measurements. And my point is, here with this in-memory OLTP is that since you can't make these changes, you need to really stop and think about your design. You're not going to just be able to go add a column, right? You're going to have to actually drop the entire table and then recreate it. Well, what are you going to do with your data when you drop an entire table, right? So that's why I'm saying if it's a Q table, that's not a big deal, because if you're eliminating records from your Q table very quickly after you get them done and processed, that's one thing. But if it's a table that you're actually trying to store heavy data or big data, that is going to be a problem, okay? And obviously it can't become too large, because then you're going to have more memory for it, right? So you have to think about these in terms of design. But it is good for many OLTP processes. And that's not to say that in-memory tables are not effective. Just consider some of the cons as well. So if you have a really good design setup, and you have a table that looks kind of like this, or tables that look kind of like this in your application, then it is something that you should definitely consider for your application.